Next, we'll see adding a node into the linked list after a given node. So inserting or inserting a new node after a given node, a new node after a given node. So this is the next option we are going to use. So for example, suppose if I have a linked list of some nodes, so there is a linked list with this setup. So there is suppose 25, 10, 15, and this is start, and this is referring to this, and this is referring to days, and this is none. This is the setup. Now my requirement is adding a node after a given node. So given node, what we do is we'll read the data of given node, which we call it as key. So that we call it as key. Now suppose if I want to insert a new node after node with key or data 10. So for that, what I have to do is I have to read key. I have to create a new node. I have to create a new node, which generally we name it as ND, and we add data to it. Suppose if I want to add a node with data 30 after 10. So for that, what we have to do is, as usual, start from the first node current and keep on check whether data is matching with key. Data is not matching, then now current should refer to this. Data is matching, stop. So once data is matching, stop. This is general case I'm talking. Now the ND should be in between these two. So ND, what we have to do, after 10 it should come, before 15 it should come. So to do this, this is current and this is ND. Now whichever node current is referring, now that should be referred by ND. So copy this value here, copy this value here. So when I copy that value here, this node is going to be referring to this. Next, copy ND here, ND into this, so that this current refers to this. Now the new node will be in bit after 10, but before here in this case 15. So this is how the insertion is made, and the statement for this, what we can do is first ND dot next, ND dot next equals to current dot next, so that current dot next, so that this particular link is established. Then current next should be uh, current next should be ND, so that this link is established. So this is how we require. Now one thing here is, suppose the required node is not found. The required node is not found means 10. Suppose if I want to insert 40, this should be inserted at the end. That we'll see later. First we'll write the code for this, the simple code. So here already we have insert at the end. I'll copy this up to here, it remains same. Up to here it remains same. So here we have to read the key we have to read. So after that, read the key. That is one more thing we have to do. So this I'll say it as key, and enter data of reference node, data of reference node, data of reference node. So that we will take it as key, and I'll run through the here run through this list. Now I'll say run through this list. So this I have to change it as name. I'll change it. So this current, as usual, we are doing. So this is insert after given given node. This is the requirement. So for this, additionally, we are reading key, and we have to search for this key. So to search for this key, what we have to write is current dot data not equals to key, and current dot next equals to not equals to none. This is the requirement. So after we reach the required node, so what we have to do, these two statements will write nd dot next equals to current dot next, then current dot next equals to nd. This is the logic. So now we'll take this logic and check whether it is taking care of some special cases. So I'll go down and use this logic. So this is the logic. I'll just some messages I'll trim here. This entire message, just this is for reference. This I'll not. So just I'll be reading so that I can have space here. So now this is the code. So we have the linked list. Assume that we have the linked list. We'll analyze this code whether it is working fine or not. Start, and this is this one, and referring to this, assume that this is 50, this is 40, this is 55. Now this is none. Now I have to enter data to insert. So I'm creating the node here. The first step is I'm creating this node. So this two, what we do is we read the data. Suppose I want to insert 45. I want to insert 45 and key is 40. Now when key is 40, so this is the ND. Now what is going to happen? Key is 40. This is key. Now what I'll do, current, I'm making it to refer this because I'm saying here current equals to self dot start. Current equals to self dot start. Current is pointing to this. Now current data not equals to key. So false, sorry, true. Current next not none, true. So current will refer to this. Now current dot data not equals to key, false. So the loop is terminated. Loop is terminated. Now current is here and nd is here. Nd dot next equals to current dot next. That means here this is nd dot next means into this we are copying this. So this points to this. Now current dot next equals to nd. That means this points to this. So it is inserted in the middle. Mid means after 40 it is inserted. Now we'll check the special case. So this is the required thing. So it is working fine. Now what I'll do is I'll undo this because it is working fine. Now my requirement is okay. What? So my requirement is I want to insert after 60, means the node which is not there. When I give a key which is not there, new node should be inserted at the end. So now current is 50, pointing to this, not matching. Current is 40, not matching with the key. Current is 55, not matching with 60. But current next not equals to none, but current next is none, so the loop is terminated. So when match node is found or we reach the last node, we are going to terminate. So suppose if the required key is not found, current will be pointing to the last node. Now what I have to do, now what this statement does, nd dot next, nd dot next equals to current dot next. Current dot next is there having none, so this will be stored none because this is going to be the last node. Current next equals to nd, that means now this is going to point to this. So When the required key is not found, the node will be inserted at the end. So that is taken care by this logic itself. The same logic is taken care. This is one thing. So generic case, generic case here is after a found node. After a found node. So if you find some node, after that it is working. This code is working. One special case is special case. What is taken care here is key is not found. Means the reference node is not found. Key is not found. So that is taken care. Now second special case, uh, reference node key is found at last node. Found at last node. Now, when you take the last node, these two are almost same because when key is found as last node, here the condition is satisfied. Suppose if the key is 55, 55, it is matching, and when current is pointing to the last node, it is terminated. Suppose if not matching, if no key is matching, because this is going to be none, this is going to be none, it is going to terminate. So for both these cases, the logic remains same, and the same generic logic is taken care. The generic logic is taken care, so it is working fine. Now one more special case here, the third special case is when the list is empty. List is empty. So that list empty is not taken care here. So it is because I'm starting directly with the current self, and I'm checking data. When the list is empty, current data I cannot refer. So whatever logic we have written when list is empty here, so this logic I can use when the list is empty. So what I'll do is when the list is empty, in this case, when the list is empty, I can use this. When list is empty, I can use this, and I can stop, and I'll say insertion happened successfully. Insertion happened successfully. Here I'll say print, or I'll write, okay, what shall I do? Okay, when it is else, so when insertion is empty, it is uh, when a list is empty, then what I have to do, just like earlier cases, start, you have to make it ND. That is what it taken care. If not, then I have to search for the given node. If not, I have to search for the given node. So this is when list is not empty. When list is not empty, this is taken care. So I'll write this here. When list is not empty, and all the generic cases, the generic case will take care of the special cases. So print here the node with the data inserted after key successfully. So this is the message I'm displaying. So the whether it is empty, whether the key is found at the end, the logic is taken care. Now, what else? Any special case? Suppose if the there is first node is the one more special case is actually it is we cannot consider it as special case. Suppose if you consider after first node, if I have to insert. See, generally the special cases will be at the edges, in the beginning, at the end. So if I take not found at the end, key is found last node at the end, list is empty, a special case after first node. So even if it is after first node, current is found here, it is going to be inserted after this, there is no problem. So everything is taken care. So inserting after a given node is also very simple logic there. Only one special case we have to consider, which is list is empty. Now we'll try to execute this. We'll try to execute this. So first I'll execute this node class. So it is getting connected. So connected node class I have had to execute. Then node linked list, sorry, linked list class. So I have added all here. Now the menu changes I have to make, like when it is insert after given, that I have to add here. So after given we have not added. Now I'll add that here. So option equals to 3, insert after given node, after given node. So this is the option 3. Now I'll compile this. Now I'll call this main from here. Now check whether it is after given node when the list is empty. Now if I try to display 5, so it should say list is empty. Now after given node, when the list is empty, I'll try. So item to insert 25, I'll do it. Then key anything I give, because list is empty, it gives the same thing. So the node with data 25 inserted after 10 successfully. Now when I say 5, so 25 is inserted. Now I'll insert attend after 25. So when it is first node, check whether it is working fine. Now I want to insert 10 of 10 after 25. So now if I say 5, so 25 10, I'll insert at the beginning. Just add some node. Suppose 30 I'll add in the beginning. So 30 is added at the beginning. Now if I say 30, 25, 10, I'll add one node at the end. I'm ensuring all options are executing correctly. So 40. So now if I say it should be 30, 25, 10, 40. Okay. Now I'll insert after 10. We'll check whether it is working fine or not. 3. Now I'll insert 50 after uh, 10. Now if I say 5, so after 10, 50 is inserted. So everything is fine. It is working fine. Now one special case, list empty, it is already taken care. Now when the required node not found, that is one thing I have to do. So I'll say 3. Now I'll insert, suppose I'll insert 20, 20 after 60. 60 is not there. So when it is inserted, when required node is not found, it should be inserted at the end. Now 20 should be at the end. So it is coming fine. 20 is at the end. It is coming fine. So that is also taken care. So all options are taken care. Now I'll check whether delete is working fine. So I'll delete the first node, which is 30. So 30 is deleted successfully. I'll say 5. So 30 is deleted. Now I'll try to delete 11, which is not there. So 4, I'll try to delete 11. So what it says, the node with data 11 not found. So the remaining thing should be as it is. Now I'll delete 20. So 4, 20 I'll delete. Now 5. So 20 has gone. Now I'll delete 10. 4, 10 I'll delete. Now 5. So 10 has gone. Now I'll delete 25. 4, 25. Now 5. So 25 has gone. Now I'll delete one more. 40 I'll delete. 4, 40. Now there should be only 50. So 4, sorry, I'll say 5. There should be only 50 there, 50. Now I'll insert after 50. Just one last test case I'm doing. 3. Here I want to insert 60 after 50. After 50. So it is inserted successfully. Now when I say 5, it is 50 and 60. So everything is working fine. So this is the complete linked list with all options executed.